My name is Srđan Kovačević, as many of you know me, and some who don't know me. I'm coming from the Faculty of Technical Sciences, University of Novi Sad, and I'm assistant of Professor Dimkić. So today I will present three presentations. Professor will not present third presentation. First of all, I will talk about analysis of the occurrence of the pharmaceuticals in surface water and groundwater, and after that about their behavior and transport in the groundwater. We have some investigation from 2009 until now, and in the first phase we detected pharmaceuticals. We monitored them in surface water of biggest rivers in Serbia, and after that in groundwater. Second phase included some experimental stuff. We did some sorption isotherms on real samples. After that we have some other sorption experiments, and after that field tracer test. And the final phase, which is third paperwork, is about that. It's about modeling the groundwater transport on the case study of the Belgrade water source. So I will, because of some technical problems and little delay, I will shortly pass through the presentation. We have introduction, materials and methods, like in all paperworks. And first, this table. As everybody is reading papers on Science Direct and all other things, and you can see that there is a lot of papers that are confirming that there are pharmaceuticals in surface water. This is an example of surface water. So there are some higher concentration, lower concentration. We can see in Germany about 1.3 micrograms per liter. In Serbia, maybe this is example for carbamazepine. He is one of the investigated pharmaceuticals. And in TISA 94 and all other data. Also, we can see that there is a presence of pharmaceuticals in groundwater. So in USA, we had 420 and so on, so on. So we have evidence that there are pharmaceuticals in groundwaters and they are in surface waters. So we are dealing with the protection of groundwater. One of the main goals is to all in the world to have the water for drinking. That is the main principles. If we don't drink water, we will not live. So we are dealing with that. Also, it's interesting to show what is the rate of the removal of pharmaceuticals. This is also example from carbamazepine. He is removing from 5% to 99% depending on the technology we are using. Some of them mentioned we can use reverse osmosis, we can use absorption, but some of them are cheaper, some of them are more expensive, depends on the economy of the state. Also, this is very interesting. We need to check and address and to monitor how they are behaving in groundwater. This is investigation from Professor Schmidt and Professor Brauch. He is not here, but he was here. They investigated how they are behave in groundwaters on different conditions, aerobic, anaerobic, anoxic, and all other things. So we can see that some of them are removing more in aerobic conditions, some of them in anaerobic conditions. As the first stage, as I mentioned, we monitor the status of surface water and groundwater. So we collect data from many sites, maybe Sava River, Danube River, Morava River, Tisa River, Nishava, and many others, and corresponding water wells. But after a few years, when we collect some of the data, we concentrated on the three investigation fields. First is groundwater alluvial of Belgrade water source, as you can see on this picture, especially this one well. Professor also talked about this, and this is very interesting. We can see some schematic strata of this site. It is anisotropic site, so we have different conditions. We have many layers, interbands and semi-permeable layers. Second site was Kovin Dubovac drainage site. There are drainage wells. These wells are built in 1980s, 70s to protect these sites from the floods because the Đerdap Dam was built in 72, and after that they were built. And third, and as I didn't mention, I will say that later. And third site was a Ključ groundwater source. It is located near Požarevac. So, to start, these are all locations that we investigated. Novi Sad, Belgrade, Tisak, Ničanin, and all other. It's not so important. There were many samples, about 167 samples total, about 60 samples from surface water, and about 110 from groundwater. So there are many samples on different locations. You can see this on this table. Also, with our colleagues from the Faculty of Technology and Metallurgy, from Professor Alluvial and her colleagues, as it said here, Grujić, Elković, Radović, they did the analytical experiments. So they prepared as it follows by solid phase extraction, tandem GCMS, and this methodology is explained in detail in other books, so I will not be talking a lot about this. Also, during this investigation, we monitored physicochemical parameters, redox potential, oxygen, dissolved oxygen, electric conductivity, and many others. And also we did some new drilling of wells. So we have all the data. This also professor mentioned in his lectures. These are the sum of the results from the paper of Dimkić and Pušić, where there are summarized conditions for these sites. First of all, for the Belgrade water source, we have the predominantly anoxic conditions. For the Danube River Kovin Dubovac drainage system, we have also anoxic conditions, and for the Ključ groundwater source, we also have different conditions, oxic conditions. So there are many data. You can see 350, 2050, so many years of work, they are summarized in one paper. Also, what is interesting, and I will tell it later in other paperworks, this is the schematic picture of some radial well on groundwater source. What is interesting, we can see this schematic permeable layer named 3. So there are many layers, impermeable layers, but when we summarize that, we concluded that we can represent all that layers with one layer. I will explain it later. Also, we have well laterals, and that is very important for the protection of groundwater source. So that is one of the main reasons why we don't have pharmaceuticals and all other investigated micropollutants on this location. I will go in detail on other presentation. Also, on Danube River, it's more isotropic. We have uniform conditions. There is a gravel, sand, and most of the water is coming from the Danube River to the overflow well. Third site is Velika Morava River. That is a groundwater source Ključ. There are oxic conditions. Also, we have tubular well. And what is interesting and very important when we are dealing with some transport analysis or all other things, colleagues from the TU VN mentioned Galonium. They investigate what is the ratio of the water from the river and what is the ratio of the water from the hinterland. In this case, we monitored some 10 years. Nitrate concentration, we have some cheaper natural tracers to monitor. Also, we have mineralization or the rate of, dry mineral rate. So we can, if we have 250 milligrams per liter in Velika Morava, and we have in same value, we can assume that there is most of the water is coming from the Velika Morava. Also, if we have piezometers right here with the concentration about 600 milligrams per liter, we can calculate what is the ratio of the water which is coming from the hinterland on. This is the most easiest way to calculate it. Now we can see some results. This is summarized table, and we can see what of this. We investigated, I didn't mention, 25 pharmaceuticals in surface water and groundwater. Some of the colleagues are doing wastewater analysis, and you can solve some results. Most of them are not detected, but with the highest frequency, there is a methyl metabolites for FA and for AA. They are detected both in surface water and groundwater. Also carbamazepine, he is also persistent. Diclofenac is only surface water, some of them in groundwater, etc., etc. We will see later. Now we can discuss something about the results. You can see on this graph that there is a significant reduction of concentration from the river to the groundwater site for the extraction, and we can see that carbamazepine concentration is lower by about 60%. Imidacloprid is completely removed because antibiotics are more pronounced to remove, and methyl metabolites are reduced by 62 and about 87% respectively. Another site which is very interesting, it's Sava River Alluvial. Almost all the pharmaceuticals are completely removed. Only carbamazepine, which is most persistent among them, is not removed. He is maybe removing in oxic conditions, but in non-oxic conditions he is removing slightly. And finally, the Velika Morava alluvium, we can see there are also significant reduction, but there we cannot quantify degradations. We cannot be sure about that, because we have some data that water is diluted from the hinterland. I mentioned about that. We measured nitrates and all other things, and we concluded that about 50% of water is coming from the hinterland, from the back of the river. So there is a significant dilution of pharmaceuticals, but they are also removing. And to conclude for this first paper, I have 3, so I'll be very quick. After that, you can ask me. We can conclude that concentration detected in 3 major rivers are significantly higher than those detected in groundwater. Rates of removal are different, but you can see for antibiotic imidacloprid 100%, carbamazepine 60%, and FA and 4FA about 90%. That is for the whole Serbia, not by the sites, but summarized data for all. And it is very important to assess the river bank filtration potential. We need to know what the processes are happening there, what is the rate of absorption, what is the rate of degradation, what is the rate of dispersion, and all other processes. And next phase, it's said here that we are undertaking, that we are doing some mathematical models, and we have some data about experimental data about absorption.